So I'm going to make a video real quick, Greg, and Joey, about what I've got here, what I found last night. So the setup here is run off these batteries. These are two 4800 milliamp hour batteries, 3.7 volts, I believe. And I've got it powering the board here, and from these transistors here, it reduces it to 5 volt. This is the other linear regulator here that reduces it from 5 volt to 3 to power this laser. And it's the program's running right now. It is running React Delay. And so I wanted to kind of show you what's going on. I've got these servos here mounted that will direct the laser to the place it's been pointed at, I guess, for the target practice. And so these things are working, and we'll just sit here and watch it for a little bit. And as the servos move, you'll see, pay attention to that red light right there. Eventually you'll see it blink when the servos actually change their position. It'll take it a while. There it goes. It's not showing up in the video as much as it is here in front of me, but that blink there is a drop in power across the entire power supply, because these batteries aren't able to handle the current draw coming from everything that's running here. Now, that's kind of just a result of the way it's running. My thoughts are, to improve this, is we find batteries with a higher mAh, hopefully somewhere around 6,000, 7,000. That'll help extend the life. Right now, I think from consistent uses, I think it's able to run reasonably well for about 15 minutes consistently. And I know that's really not the use case for you guys, but that's kind of how I'm measuring things. And the other thing to help improve the load is, if it's possible, to turn these servos on one at a time, such that as it's changing position, it turns left and then goes up or down, whichever way it needs to go to point to the target. I'll remove one of these guys. If it's only powering one at a time, the batteries can handle the load, and it does it pretty consistently. We'll sit here and watch a little bit, and you can see it's still got the laser on and the delay sequence is running, and so this runs consistently without actually pushing the batteries to the point where they can't carry the load. So I wanted to show you. It's kind of hard to explain without seeing a video, so I wanted to make a video of it so you can kind of see what I'm talking about. I don't know if it's possible to turn one on at a time, because I think we're using the ESP32 servo library, but it's just something I would bring up. Otherwise, we're going to be faced with potential I guess, erratic events. Because if these batteries aren't gonna, that as they continue to be used, they will get weaker, and the weaker they get, the worse these load drops are going to get, and things will just won't work right. The servos will be off, and they probably won't point exactly where they should after they have been set and configured. It'll eventually miss its mark, and then the interrupts that are running in the code may start to fail as well, because the timing will get off on the microcontroller as well. So anyway, these are just some of the things we typically run into when doing something like this. These the main culprit is the laser. These are good lasers. They're bright, and you can stand out. You can really see it in the daytime. I understand why you guys need these things, but right now they're the culprit for all the power draw. I can't get the power draw down to, I think the lowest I got it was about 250 milliamp. They do have a, what's wrong side? They do have a pot on them, and so it does lower it down. But the trade-off is the intensity of the green light isn't what it typically is. And that's probably not. I mean, I don't know how bright it needs to be, but I think that's something you guys are really want to maintain in the design. So anyway, that's kind of where we're at. I guess we can catch up later and talk about it. But I wanted you to kind of see where I'm at with this thing. It came together a lot quicker than I thought it would. The code works very well, easy to understand, and so you guys have done a lot of work on this thing. So once I got everything hooked up, the other thing is I've got these capacitors on these servos too, and they helped a lot with the jitter that I had. I don't know if you guys are still facing the same thing, but that'll be something I'll add into the design too when I actually finish up the schematic. But anyway, I think that's enough for now. I'll send you guys this video, and we can figure out when we can catch up and just talk about see what you guys thoughts on this stuff.